So on the bench today, we have this Systron-Donner Model 114 counter that came up at the local electronics recycle place. And it's a 6-digit NIXIE tube counter. It's NIXIE, which makes it cool to begin with. But this little case is just amazing. The case is what caught my eye the most. I just think it's a beautiful little unit. The aesthetics of the case are just awesome. It almost looks like something you might have seen in Star Trek, the original series. You know, it's got a 1 megahertz output, it looks like. It can do storage on or off. External or internal gate. It's just an amazing little box. The base is metal. This front bezel's metal. The timing on it's 1 sec, or 0.1 second, 1 second, 10 second, 100 second. Pure count or hold mode. There's of course a sensitivity input. I'd look at the sensitivity. I can see through the silk screen here there's a hertz, kilohertz, and can't really read that one. And then a gate. There's probably a neon bulb behind them to make them blink. There's the recycle rate for the screen. I'm assuming that's also the power switch. And of course a reset. Don't know if it works. I didn't bother to plug it in. See, I was completely compelled by the case. I have some other NIXIE tube gear here. I have a Simpson 7026 NIXIE tube counter that I did a restoration on. It's actually a really nice little counter for what it is. I did spend a bit of time looking inside with a flashlight, and I could see a couple 7490s in there from 1968, which seems appropriate. Apparently Rosie wants my attention. You know, a couple 7490 decade counters from 1968. So it's not quite as old as I am. I wouldn't be surprised to find 74 Rosie, shush, 7441, 7143s. They're a BCD to 10 output mux, or demux, however you want to call it. It's not even really a mux, a decoder that basically, depending on the BCD value from 0 to 9, pulls one of the outputs low. The output is high voltage tolerant. You can use that to pull the individual segments low on the NIXIE tubes to get them to light up. Inside of this, I would expect to find a 180 volt DC supply. Might be 170, might be 190, but around 180 volt DC supply to power the tubes. We know there's some TTL logic in there at 74 series. There'll be a 5 volt supply. I'm sure it is completely linear. Although the input, well, that's a model number. The model number is 114-302. It's serial number 686, and it's rated for 10 watts. It's going to be 120 volts, AC 60 hertz in, I'm sure. So anyhow, I thought we'd give this a bit of a teardown and take a peek inside. I'm actually curious to plug it in and power it up. I hate to do that without looking inside first. I'm not going to violate my rule here. I'm going to open it up and take a look inside first to make sure it's safe to plug in. So let me get the skins off and we'll take a look inside. So with the 2 screws removed here out of the back, it's obvious the chassis slides out. So we'll go ahead and slide it out here, and I'll get the power cord pulled through as well. And set the little case aside. And here we have the unit itself. So there's the 7490s I spotted. There's date code of 33 week of 70, 33 week of 70. Must have been there was 2 of these. One was a 4-digit, one was a 6-digit. So maybe the other one had the 68 date codes. Anyhow, there's 474. There's 3 7490s here and a 7447. There. Try to get it up here where you can kind of get a view inside. There's more TTL logic, 68th week, or 18th week of 1968. It's interesting that pin 1 orientation is flopped back and forth on these. They're not all the same orientation. Probably made the PC board a little bit easier. There's a 7441, another 7441. So the 7441s are the BCD to 10 decoders to drive the displays here. Pretty standard looking power transformer. There's a Sprague electrolytic cap hidden back in here. There's actually two of them. I'm sure one of them's for the 180 volt, the other's for the 100 or the 5 volt. A couple little trimmer pots hidden away in here. You know, various discrete logic. The input is sitting here. It's AC coupled through a capacitor. It goes straight into one side of the potentiometer. The other side of the potentiometer is grounded. The power switch is on the potentiometer, and then the center tap of the pot comes through the coax down onto the board here. So this is going to be the input conditioning to get that input to a TTL compatible signal. To drive the decade counters, there's another 7441. So there's 6 7441s across there, one for each NIXIE tube, which makes sense. It's not multiplexed, they're directly driven. There's a crystal here on it that is it really 1,000 hertz? 1,000.000 kilohertz. Okay. So, you know, and it's stamped at 3 digits precision, 1,000.000 kilohertz. Which is nice. You know, a little bit more discrete logic hiding along here. It's clean inside. I don't see any obvious signs of smoke and fire. I don't know if you can see these, if I can get them in camera there. These gold devices. This one's a 74. Can't really see it through the shadow. 74, is that a 90 again? There's a 7490 there in the gold package, a 7490 there. So there's 3 7490s in this gold package. It looks like it's a white ceramic with a gold top. They are labeled 7490, so it's not like a mil-spec 5490. Date code is 10th or 18th week of 68. It's obviously all through-hole construction, no surprise. Looks like it's a nice hand-taped board layout. There's a single bodge wire here. I can't tell if the tubes are socketed or not. I think they're socketed, looking at the pins that are soldered in here. So I'm sure we've got the 7490s to drive the tubes, then we've got the decade counter stages. This is probably a pre-scaler, would be my guess. The wires from it come off. Looking at the color codes, probably to this rotary switch here in the middle, which sets the range. Line cord's in good shape. A quick visual of the line cord. There's no bad nicks or cuts in it. You know, there's a little bit of gouging here, but it's not through the insulation. I see nothing dangerous about this line cord. Besides, it's almost 50 years old. Fuse holder. Can't tell if that fuse is blown or not. I don't think so. I think that fuse looks intact. If I can get it to go back in. There's a trimmer capacitor of some sort along here. I'm sure that's a trimmer cap to trim the device, and it does come up to another trimmer cap here near the crystal, so that's going to be where the clock is trimmed. I think at this point we're probably safe to power it up. I don't see anything extremely dangerous. Obviously those 2 electrolytic caps in there are ancient and they may well be dried up and dead. It'd be some work to tear this down to replace those 2 caps. I really only see the two electrolytic, and there's some, I don't know if that's an electrolytic or a polyfilm, but it's a non-polarized. There's a little polarized down here that's probably like a polyfilm or a little built-in test point there. I'm not sure how much of this is showing up in video. It's mechanically an interesting build. It kind of all centers on the steel plate here through the middle with the transformer mounted on it. Then the back panel is mounted to that. Yeah, and then there's a screw from the steel plate into the plastic casting here that has the 7-segment displays inside. Anyhow, I'm actually gonna power it up upside down just so I can keep an eye out for smoke, failing capacitors. But at this point, let me take one more look and make sure the camera's recording, since this can always be the most exciting time. And we'll give it a bit of power. And it came right up, and the NIXIEs look nice and clean. The reset works, everything's zeroed. Of course, there's now 180 volts sitting inside of there for driving the NIXIEs. Let me sit it up here a bit. Hopefully you can get a little bit better camera view down into it. It doesn't want to sit very stationary. Let me look and just make sure you can see the unit. And we'll bring it up. Let me reset it, get us all back to zeros. I don't want to shock myself here. Ooh. I just want it to sit here. Guess we'll have to feed it a signal, and so of course the gating speed, you can see the gate. Let me take it down to something fairly quick. So kilohertz, you can see the gate light flashing as it counts. So I think the next step is to feed it in a signal and see if we can actually get it to count. So I'm feeding it a 1 kilohertz sine wave, 5 volt peak to peak, from my Rygold DG1022. Let's play with the sensitivity and see if we can get it to count here. Oh, I need to turn the output on the signal generator. That might help. And let's see, we're counting kilohertz, so there's 1 kilohertz. So it is actually counting. Let's give it a little longer time base. There is 1 kilohertz again. So that actually looks nice and solid. Get it to gate as quick as it can. Every time you see the gate, it's final or totalized to count, and it's displaying it. So let me give it 1001 hertz. And there it is, 1001 hertz. Nice. 1059 hertz, just to pick a value. 1059 hertz. Take it up to 10k hertz. And once we come around, we're clean. So it might be counting a little bit under. We saw it flash down to 9999. There it is again. So it's counting a little bit less than 10 kilohertz. We take it up to 100k hertz. And a little bit of error at 100 kilohertz. It's just shy. 990. So that's 990 kilohertz, and it's counting 989.985. There's a little bit of error here. No surprise given how old it is. Sometimes mucking with the sensitivity can help, but it looks to me like it's triggering very solid. If we take it to 10-second count and reset it, it should take 10 seconds here to count all the way up, which can take a bit. There it is, so 89.98, and we're at 990, so there's a little bit of error there. I don't know how high a frequency can go to. Let's try 50 megahertz. Obviously, it's not going to be able to count 50 megahertz. What am I thinking? Or can it? Yeah, it should be able to go to... Let's see what we get here. Am I reading the scale wrong? And of course, the gating on this is going to take 10 seconds before it updates the display. It gated, and so let's see. With this reading hertz, that would be 99,000 or 999,000. Would be boy, I can't read that right. 99,999. So that wouldn't quite read a megahertz. I don't know what I'm thinking, dumping 50 megahertz into it. So I'm going to go ahead and give it 98.765 kilohertz, and we'll see if we actually end up with a 987 here on the display. What was I thinking? 50 megahertz. 98763. So we see there's a little bit of error there. It's off by about 1.4 hertz. Assuming my DG1022 is accurate, which I do believe it is. And if we go up to 100 count, again, 100 count is hertz. Hertz. That's kilohertz, so that's good to 999 kilohertz. And that should be able to count to, let's see, it's in kilohertz. Reset it. So I'm giving it 990 or 9,999 kilohertz, so just a tad under a megahertz. And again, there's a bit of error, no surprise. With a bit of tweaking, calibration, may actually be able to fix it. These NIXIE tubes are interesting because they actually have a decimal point in the tube. Not sure what tube numbers they are. But it's actually a neat little unit. The case really makes it very cool. Part of me is wondering what I could do with it. I don't really need another NIXIE tube frequency counter. It's very cool the way it is. However, it would clean up well. Part of me is considering doing something like maybe a YouTube view counter or subscriber counter, or maybe a combination of things that could be selected off the rotary switch. It would be really cool to be able to watch, views on my channel, or subscribers, which are slowly increasing. Hopefully, if you're watching this video, you subscribed or will when you're done. Interesting piece of almost 50-year-old tech. Interesting, because I would expect that to overflow. I'm feeding it 909,000. Feeding it 9.999. Oh, megahertz. I read this wrong. 9.999 megahertz. Anyhow, killing the sensitivity, it should as it did collapse. Take the amplitude and I'm going to cut it down to 1 volt. And we'll bring the sensitivity up and see if we can get it. There it goes. Count off the 1 volt, and we're right at the maximum sensitivity. There's 0.5 volt peak to peak. I'll jump down to 25 millivolts peak to peak, and I expect it to not be able to count it. 200 millivolts, so it'll trigger at 200 millivolts. Let's change the waveform to be a square wave. Go back to frequency and take it down to 5 megahertz. And now we can go back to a sine wave, or a square wave, I mean. So it's not liking the square wave. Amplitude will bring up to 0.5 volt. One volt. Oh, I was being stupid there. That was totally on me. I was giving it millihertz, not megahertz. So there's 1 megahertz. Amplitude is at 1 volt peak to peak. Let's go back to 0.5 peak to peak. So there's 0.5 volt peak to peak. Quarter volt peak to peak on the square wave. It's still happy. 0.2 volts, 0.15 volts. It's still triggering, like very happy. 0.1 of a volt. $50 millivolts, and it's starting to see issues at 50 millivolts, which is no surprise. But you know, it's around 1/10 of a volt minimum input, which is nice, and that's with a square wave. Bring it back to a sine wave. It does clean up a bit. Still off by a little more than 0.01 hertz. I believe, am I reading that right? 1 megahertz, 900, yeah. 999 point, that's actually worse than that. So this should be 1 megahertz, and it's just under 1,000 kilohertz. So anyhow, there's a quick look at it. I will put it back in its little case and give some thought as to what we're going to do with it next. So I'm feeding it a 9.876543 megahertz. Hopefully you can get a good view there into it. You can see it's back in the case. Check the camera. Yeah, it's a pretty good shot. You can see what it looks like here in its little case. Of course, it pivots up and down, which is very nice. It was up on a shelf. You could tilt it down. If it was low, you could tilt it up, obviously. Just a really cool little implementation. Pretty much what I expected inside. TTL logic. Date codes from 68, early 70s. A few interesting parts of TTL in there, and the ceramic packages with the gold tops on them. Those were interesting. You know, that should be, is that what the OR is? The little OR up there is over range. So I see now what that is. Or overflow is what I would have called it. But yeah, that's the indication that it's over range. So, neat little meter. The system, or the sister unit of this that my friend got, had a Boeing sticker on it. So I'm sure this came out of Boeing at some point. There's still interesting stuff from Boeing that shows up here from time to time. Say these ended up at a local electronic recycler who recognized them as NIXIE, and although he has no interest in it, he knew some of us like our NIXIE tube stuff. So, interesting little device. I hope you enjoyed the short video here on it, and we'll talk soon.